Hello everyone, welcome to the first module of Statistics and Probability full course. My name is Sumit Shukla, a data scientist and an educator. In this particular video, we'll be talking about Introduction to Statistics and Descriptive Statistics. We'll be also talking about measures of central tendency and measures of variation. So let's get started. So let's start with, first of all, talking about statistics. Now, if we talk about statistics is broadly classified into three major categories. So let's discuss about them. And I will be writing all these notes. So if you feel like increasing the speed of this particular video, you can do that. But I'll be going in my very normal pace. So you can just adjust your speed about this video as you like. So statistics, the very first category is descriptive statistic. Then we have inferential, and finally hypothesis. We'll be looking at all these three segments in a very detailed way, but let's start by understanding a little bit about each of these categories. So we will briefly talk about what is descriptive statistics, what is inferential, and what is hypothesis. Let's first take some random data. Let's say we have this kind of data. So we have the data of, let's say, few students with their student ID, the name of the student, their marks, and let's say their age and from which city they belong to. So for a student ID, I'll just write SID, then name, marks, age, and city. And let's say we have few data points. Let's fill these tables with some random data. So 0, 1, 0, 2, 0, 3, and so on till 0. Let's say we have some 1,000 students. So 1,000, name is, let's say, Sumit, maybe Ravi, Sanju, and Ankita. Then we have marks, let's say 100, 95, 82, maybe this is 60. Then age, let's say 29, 28, 25, and 30. City, so I am from Kanpur. Then Ravi maybe from Bangalore. Then maybe this is Chennai. And finally Ankita from, let's say, Jamshedpur. So we can just write Jamshedpur. Okay. Now, given this particular data, we have to understand this data. So if your manager, or maybe let's say the principal of a particular school, is asking you to summarize this data, now you will not be able to provide the information regarding each student, right? So you will not be going to your principal or maybe the head of the school to explain the person that, okay, we have Sumit, we have Ravi, we have Sanju, we have Ankita. The marks of Sumit is 100, the marks of Ravi is 95, the marks of Sanju is 82. It will take a lot of time and it is also not feasible. And the head of the school will not be having this much time to listen to all your information. So what he or she is looking for? He or she is looking for some information that can fully describe the complete class. So what is the metric that we can use to consolidate or to better describe the complete class is what descriptive statistics is. For example, I can say that this particular class is having number of students as, let's say, 1,000. Now this is a statistic which is describing the class and hence descriptive statistic. Let's say the average marks of this class is 85. Again, this number, just this one number, is describing the complete class, and we will be talking more about what average is, but this number is talking about the complete class, and hence this is a descriptive statistic. For example, let's say the average age is, let's say 25. Similarly, maximum marks, then we have minimum marks. So all these numbers which describe the data in such a way that we just need this number to explain the complete data points is basically known as your descriptive statistics. It's very simple to understand, right? Now we have descriptive statistics can broadly be classified into two kinds of measure. So I'll just change my color and we'll write over here. So one is known as measures of central tendency, and then we have measures of variance, or you can say it is measures of variation. So I'll just simply write it as measures of variation. Okay, so we will be talking in detail about what are the various measures of central tendency is and what are the measures of variation is. So what we have learned regarding the descriptive statistics, it's basically those metrics that can define the complete data, or that can help us define the complete data. We do not need to look into each and every row. We do not need to look into each and every information. Remember, in a particular data which is cross-sectional, having rows and columns, each row is known as the information. So using the power of descriptive statistics, we do not have to go through each and every information. We can just use these metric to describe the complete data, right? Then we have inferential. Now, how we can understand inferential? So I'll just quickly change the color and we'll take one example. Let's say that is company, let's take any name of the company. Let's say there is a company known as Scalar. Now Scalar wants to know on an average how many hours a student is studying in 12th class. So what's the question? How many hours a student studies when the student is in 12th class. So I'll just write in bracket 12th class. Now if I look into this problem, overall there will be millions of students in India, right? And if I just limit my scope of study to India itself, so there will be a lot of students that will be present in India right now, those who will be in 12th class right now, right? And it is impossible for any company to perform survey in such a large scale. So let's say if Scalar has to get this number, Scalar has to basically get an average number. So I'll just write average. How many average hours? So how many, or maybe just simply write it as what's the average number of hours. So what's the average number of hours a student studies in 12th class? In order to find this answer, how we will take the procedure or how we will take the approach. So let's say this is my complete population, all the students who are in 12th class this year. So 12th class students. Now there will be so many students, right? If I just have to take a number, let's take there are 100 million students. I'm just throwing a number. So 100 million students. In order to get this statistic, which is what's the average number of hours, I have to reach out to each and every student. So let's say the entity scaler is performing this survey. They will reach out to each and every student. They will ask the student whether the particular student studies for 1 hour, 2 hour, 3 hour, 4 hour, or maybe n hours. Then we will collect the data. The scalar team will collect the data. So let's say we have the data of student number 1, student number 2, student number 3, and so on till student number 100 million. Now once we have this data, we will take the average, and that is basically my output that I'm looking for. Now if we practically look into this procedure or into this problem, seems like this is practically impossible, because it is practically impossible for any company or individual to reach out to these many people, or to reach out to these many observations or entities or individuals. You can call it anything, right? If even it is possible, it requires a lot of time and lot of money, lot of investment. So what are the practical problems? Number one, a lot of investment, a lot of time investment. Similarly, a lot of cost investment, a lot of cost investment. So we have to invest a lot of things, and none of the companies having this much time. So what is the practical solution for this? Well, the practical solution is very simple. What we are going to do, we are going to take some few students which we call as the sample, and we will also talk about how the sampling is performed. When we will be discussing about inferential statistics, we'll be talking about how sampling is performed. So let's say we are having a simple random sample, and the term simple random sample I'll be explaining you in a better way, so don't worry. So let's say we are having a sample. I have taken some random students. Let's say we have taken 100 students from Uttar Pradesh. We have taken 100 from, let's say, Andhra Pradesh, 100 from Tamil Nadu, 100 from Delhi NCR region. So like this, we have created a sample, and let's say this sample is having around 1 lakh student, 1 lakh. Now, in order to perform survey on 1 lakh people seems quite practical, right? We can perform the survey on 1 lakh people. So let's say after performing the survey on 1 lakh people, we have the data with us, S1, S2, and so on till S1 lakh. And now we can take the average. Once we have the average, this is known as the sample average. So I'll just write mu. Mu is a Greek letter which is commonly used to represent average. So average, then I'll write S, sample average. I'll just write it in brackets also, sample average. Now inferential statistics is a branch of statistics which deals with approximating the population average or population parameter. Remember one thing, if I am talking about the average of population, it is population parameter. If I am talking about the average of sample, it is sample statistic. So there is a difference. So please remember, when I'm saying a statistic, I'm basically talking about sample, because practically it is impossible to do anything on population. There are two problems. Either we are not able to reach out to all the observations in the population. So if I ask you, find out the average height of Indian men. Now it is impossible for any individual to reach out to each and every Indian male, right? So that's basically my population, and if I can get that number, if I can get the average age of all the Indians in this, all Indian males from India, then that is known as the population parameter. Okay, so inferential statistics, coming to our point, inferential statistics is a branch of statistic which help us to perform approximations. So using this sample statistic, I will try to approximate the population parameter. So let me just quickly write it over here. Using sample statistic, we will try to approximate the population parameter, and that is basically known as the inferential statistic. Now there are some procedures, we have some few formulas, we will be talking about that, but this is basically the brief idea behind why we need inferential statistic. Okay, the last portion, or maybe the last segment, which is known as the hypothesis testing. When we talk about hypothesis testing, as the name suggests, we are trying to test something. Now what we are trying to test? We are trying to test something which has been proven, or maybe a claim, or maybe an statement. There can be anything that we are trying to test. Let's take one very general example. So you guys would have watched this Dettol advertisement which says that Dettol kills, or Dettol soap kills 99.9% of the germs, right? Now let's say you are suspicious about it. You are suspicious. You wanted to test whether this claim or statement made by the Dettol company, is it having some statistical significance or not? Is it statistically correct or not? And that is where the power of hypothesis testing comes into picture. So we will try to test here. We perform test to check if a particular claim or a statement can be statistically proven. Can be statistically proven. So these are the three major segments which we are going to discuss. Now before we jump into any of these segments, we have to understand what kind of data we are working with. So we will be briefly talking about how we can explain a data. And when I say explain a data, what are the various types of column or variables we get in a data. So let's talk about it. We will be taking one very random example. So let's just quickly create a data. Again, we can extend the same example that we have taken in the last slide. We were having student ID, the name of the student, salary, age, or instead of salary, let's put marks, age, then city. Then we can go about writing grades and maybe subject. And finally, we can talk about the gender. Let's fill this table with some few data points. So let's say we have 01, 02, 03, 04. Name is Sumit, Amit, Ajay, Ankita. Marks is, let's say, 89, 98, 95 and 62. Age is 29, 28, 25 and 30. City is, let's say, K and P, B and G, R and C, and let's say T A T A. Then grades A, B, C and B. Subjects, so let's use S1 as subject number 1, S2, S1, S3. Gender, male, 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 female. Now this is my dummy data. Now if I ask you, are you guys able to observe any kind of distinction among all the kind of variables that we are having in this data? So remember, these columns are also known as, so these columns are also known as the variables. So I may be using the term variables or columns, and as I have told you that each row is basically my group of informations. So each row is my information. Now if I carefully observe marks, age, these two columns are my numerical columns. And why I am calling it as numerical? Because the data which these columns are holding are the numbers. These numbers are something that lies between a minimum and a maximum, right? So marks can be between 0 to 100. Age can be between, let's say, so since it is a school, let's take 25 to 35. Then if I talk about city, grades, subject and gender, all these are my categorical columns, categories, because city is having Kanpur, Bangalore, Ranchi, Tata. These are all categories, right? Grades A, B, C, D, categories. Subject S1, S2, S3, categories. Gender male, female, category. Similarly, this name is a categorical column because each name can be termed as a category. The student ID is a identity column. It is neither categorical nor numerical, so I can just simply call it as an identity column. Now there are in order to better explain these columns, we have a formal name given to all the numerical columns and all the categorical columns. Let's talk about it. So when we talk about variables, it is formally divided into qualitative and quantitative. Now, qualitative data is basically those columns which consist of non-numerical data. So columns which consist of non-numerical data. That's basically my qualitative data. Quantitative data is those columns which consist of numerical data. So simply I'll write numerical data. Numerical data. Now within qualitative, there is a further distinction which is your nominal and ordinal. Now what is nominal? So when we talk about nominal, these are those columns which consist of categories that does not comes with any kind of order among the categories. For example, I'll first take example. For example, city. Let's say there is a column city and the column is having categories as Kanpur, Delhi, and then Mumbai and Kolkata. Now, I cannot say that Kanpur is better than Delhi, Mumbai is better than Kolkata, because these are four distinct categories. They do not have any kind of orderness among them. So this is simply the nominal categorical variable or nominal qualitative variable. So I'll just write down the definition. Categories that does not follow order among them are basically known as nominal data. Ordinal data, you guys would have already guessed it. It is basically those categories that follow orderness among them. For example, grades, or for example, if I say grades is the best example. So grades, so grades can be A plus, or maybe I should write A plus first, or let's take A B C D. Now we know that A is better than B, B is better than C, C is better than D. So there is some orderness among these categories, and that's the reason ordinal data. We can also talk about class, like first class, second class, third class, fourth class. So there is orderness. If I talk about, let's say, your educational qualification, so let's say a person is graduate, a person is postgraduate, a person is intermediate. So I know that high school, then we can have intermediate, then we can have graduation, and then post-graduation. So these are the four categories which will definitely have a order among them. So these are known as the ordinal qualitative variables. Now quantitative, as the name suggests, these are those variables which can be quantified. Quantitative means quantified. We can extract some quantity out of it. For example, minimum, maximum, we can perform addition, subtraction. So we can apply all those mathematical operations on these columns, and after applying the mathematical operations, the value will still make sense because they are quantitative. Now, quantitative are further classified as number 1, discrete and continuous. Now, when we talk about discrete, now these are those quantitative variables which will have values that cannot take decimal values, or that can only take integer or natural numbers. For example, number of students in a class. Now we know that a class can have 2 students, 3 students, 4 students, 100 students, 200 students, but a class cannot have 22.57 because this practically does not make any sense, right? So this is discrete quantitative variable. Similarly, number of citizens in a country, again, it will always be a natural number which is countable and finite. So I'll just quickly write it in a bracket: countable and finite. When we talk about continuous, these are those variables which are non-countable or uncountable and infinite. Uncountable and infinite. Let's take an example and it will make better sense. For example, let's take income. Now, income of a person can lie between a minimum and a maximum value. For example purpose, let's take the minimum income is 100. The maximum income is, let's say, 1 million. Now, between these two numbers, I have infinite number of observations that are valid. Can a person earn, let's say, 100.15? Let's say these are in dollars, so it will make more sense. So, is a person earning 100.15 a valid income? Yes. Is a person earning, let's say, 1 million, or let's take a smaller value so that you guys can understand it. So let's say 1265.778. I'm going very I'm taking more decimal values just to make you guys understand that this is also a possible value which can exist and which is practically possible. So a person can earn this number also, right? So between 100 and 1 million, I have endless possibilities, and each possibility or each observation is possible to exist. Similarly, we have age. Now let's say our minimum age is 27, maximum age is 35. Can I have a person with the age 27 years, 5 months, 6 days, 4 hours, 5 seconds, 6 milliseconds, 7 nanoseconds? Yes, practically possible. So at every nanosecond, I can have a particular observation that can lie in this scale. And that is the reason age is also a continuous quantitative variable. If I go back to my example, we can see that both marks and age, they are your continuous quantitative. Similarly, if I look into grades, they are qualitative, but it is ordinal. Then subjects, they are qualitative, but it is nominal. Similarly, grades, gender, qualitative, nominal, because I cannot say male is better than female or female is better than male. So these are two categories and it is nominal. City, again qualitative, nominal. So I'll just write Q-N. So name, again qualitative, nominal. And I have already told you that so student ID is basically an identity column. It is neither qualitative nor quantitative. So this is how we describe our data into various types of variables. Now we are going to talk in very much detail about what are the various measures of central tendency is and what are the measures of variation is. So with this particular topic, we will initiate the first category or maybe first group of discussion or first branch of our discussion, which is talking about descriptive statistics. Now let's try to understand what is descriptive statistics. As we have discussed previously, that descriptive statistics is all about describing the data in one number or in few statistics parameters in such a way that it can describe the complete information. And if I go back to my first slide, here you can see that I was having the data of some students, their name, marks, age and city. And if the principal of this following school ask the teacher that, okay, tell me how your class looks like. Now the teacher will not be taking the principal to each and every row or each and every information or each and every detail of the student. So let's assume that if I am one of the teacher, I would not say my principal that, okay, I have a class who is having Sumit, whose age is 29, whose marks are 100, and then we have another student whose name is Ravi, who he is from Bangalore. He's a 28 years old. As you can see that it will take a lot of time, and I would not be getting a complete picture of how my class looks like, right? And that is the reason we have these descriptive measures. And as we have discussed before, the descriptive statistics measure are broadly classified into two buckets. Number one is measures of central tendency and measures of variation. So let's try to now deep dive into these two particular topics. So descriptive statistics. As we already know that we have two measures of central tendency, and then we have measures of variation. You can also say it is measures of variance or variation. To be in general English, we can call it as measures of variation. Now what is measures of central tendency? As you know that if you carefully read the name, it says measures of central tendency. We are talking something regarding the center. Now, is it the center of the data or is it center of all the observation? Let's try to understand. Before we can quantify, before we can find out any of these measures of central tendency, we need some data, right? So let's create some hypothetical data of a class, and we have age. So let's say we have age of some 10 to 15 people, and let me just throw some numbers on my screen. So 24, 23, 26, then 21, 26, 27, 28, then one more 28, one more 28. Okay, let's make it as 26, then 32, 26, 29, and finally 28. This is the data I'm having. Please remember, each data point over here describes a particular student. So here we have a student number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. So we are in total having 13 students in our class. Now, how I can explain the complete data in one number? Well, we would try to extract that particular number which lies in the center of the data, so that we know that below this number, so assume that this pen is the center of the data. So I know that below this point I'm having few observations or few students, and above this point I'm having few students, and it will give me a better idea about how my data looks like, right? And that is what the measure of central tendency is. In this particular data, the very first measure of central tendency is the mean or the average, and many of you would have used it already. So mean, or also known as the average. Now I hope you guys already know the formula. If you don't know, it is basically the sum of all the observations divided by the number of observations. Mathematically we can write it as summation of, so this is a Greek letter again, summation. I'm taking a summation over over S, and S is nothing but my student number, so SI, or just write it as SI divided by N. So if I expand this, it would look like this: S1 plus S2 plus S3 and so on till S13. This is my sum of all the observations divided by N. Now here you already know that we have 13 students, so divide by 30. If I solve this, so I have already done the calculations just to save some time, but if you want, you can pause this video, do the calculations, and I would suggest all of you to please have a pen and paper with you while you're watching this video, so that you can also fully understand the complete concept. So please watch, please stop the video, please pause the video and calculate it by yourself. If you have already calculated it, it is basically 26.46. Now this is the average age. What is the meaning of average? Assume that I have a number line. Now in this number line, this point 26.46 is lying at the center of the data, or maybe at the center of the number line. Now it might be at exactly center, it might not be exactly at center, but moreover it will be around the center. So assume that this is this particular data point, which is nothing but average, and average can also be written as X and this bar. So if you put X and over it or above it you put a bar, it's also known as X average, or we can call this as S average, because here we have assumed that this list is S. So this particular number is my S average. Now what we can understand from this number? We can understand that below this point I'm having few observations. Above this point I'm having few observations. Now you already know that in the class I'm having 13 people. So what we can conclude? We can conclude that in the class of 13 students, we have few students above the age of 26, and I'm just taking 26, and few students below the age of 26. So we are having few students above 26 and few students below 26, and this 26 is basically describing the center of my data. Now it might be exactly the center, it might not be exactly the center. Why? Let's try to understand this. Let's say given this data, I intentionally add a particular observation. So let me add one particular observation, 40, or let's add 50. So I'll write it over here, and maybe let me change the color, 50. So I've intentionally added a student whose ID is 14, and the age of this student is 40. And even if you look into this particular data, which is having 13 students, you can see that almost all the students are having age in 20s, which is 21, 22, 23, 24, till 29 we have a lot of observations, but there is one student whose age is 32, right? Now these observations are basically known as outliers. Let me just remove this for a particular data point, and let me write them in ascending order, and that would actually help us to derive the another measures of central tendency. So I'll write age is equal to, now the minimum number over here is 21, so I'll just draw a line over here, 21. Then we have, So we don't have 22, so we have 23. So I'll write 23 over here. Then we have 124. So 124. Then we have, I don't think we have 25, so no 25. We have 126, 226, 326 and 426. So 26, 26, 26, 26. Then we have 127 and only 127. Then we have 28, 28, 28, 28, 28, 28. Finally, we have 129 and 32. 29 and 32. So all I have done is just rewritten all the age of all the 13 students in ascending order, where this is the minimum age and this one is the maximum age. Now if you carefully observe, you can see that 32 appears to be very different from majority of the data. Now this observation is known as the outlier. So this is known as outlier. The formal definition of outlier is that particular observation in my data which is very different from majority of the data points. So let me just write it down. Outlier is that particular observation in the data that is very different from majority of the data points. So if you carefully observe, here majority of data points belongs to 20s, 21, 22, 23 till 29, but suddenly there is a number 32, and that is basically the outlier. Now what is the problem behind this outlier? Why outliers are problematic when we talk about the descriptive statistics? If I try to look at the median, now what is median? Median is another measure of central tendency. So what is median? Median is another measure of central tendency. So we have already talked about mean over here. Then we have median. Median is exactly the center of the data, exactly center. When I say exact center, that basically means above this I will have 50% people, below this I will have 50% people. So it is exactly the center. How we can find out median? So there is a simple formula, n plus 1 divided by 2 if the number of observations are odd. Here we have odd number of observations, 13. So 13 plus 1 divided by 2 is 14 divided by 2, which is 7. So my 7th observation is the center of the data, or is the middle point of the data. And let me just quickly mark it. So it is 1, 2, 3, 4, 5, 6, 7 over here. This is my center. Now if you if you just calculate, if you count below this 26, below this middle point, I'll just write M to depict that this is a middle point. I am having 1, 2, 3, 4, 5, 6. I'm having 6 observations. Above this 1, 2, 3, 4, 5, 6. I'm having 6 observations. So median describes the exact center point of the data. So what is median? This value lies exactly in the center of the data in such a way that we have 50% observations above this point, and here we have taken M, so above this point M, and 50% observations below this point, and again this is M, so below this point M. So median describes the center of the data in such a way that it is lying exactly at the center, where 50% of the data is below this point, 50% of the data is above this point. While I cannot say the same thing for average, and you can see why. Average is basically taken out by considering all the data. When I have to calculate average, I am summing over all the data. Here you can see the formula. The formula is sum over all the data points divided by the number of data points. And due to these influential observations, which are known as outliers, my average can shift towards the outlier. Here you can see mean, as I have told you, mean is also the center of the data, while median is also the center of the data. These both metric describes central point of my data. But why there is a difference? Why my average is 26.46 and why my median is 26? So my median is 26. Now this is because of this outlier. So where I'm having outlier on the higher end. This is my higher end. So what has happened to the mean? My mean has also shifted towards the outlier. Now please remember this. I'll just write down as a note over here that your average gets impacted with the presence of the outliers and will shift towards the outlier. So if my outlier, so assume that if this is my number line and if my outlier is on the lower side, then my average will shift towards the outlier. So my average will shift towards the outlier. If my outlier is on the higher side, then my average will shift on the higher side. And we have already seen this example. My median was 26, but my average came out to be 26.46 because my average has shifted towards the outlier, right? Then we have one more measure of central tendency, which is mode. And mode is very simple to understand. Mode is the observation with the highest occurrence in the data. So let me write the definition over here. I'll just simply write it as observation with maximum frequency. Observation with maximum frequency. So if you carefully observe in this particular data, I'm having the observation number 26, not number 26, observation 26. This observation has appeared for 4 times, right? So the frequency is highest for the observation 26, and hence my mode of this data is 26. Mode of the data is 26. Now there might be cases where you do not have any mode. For example, let's say I'm having 4 observations 26, or there are 4 students with the age 26. We also have 4 students with the age 28. Now in that case, when there is a tie or there is no mode, so you will simply write no mode. In that case, you have to use mean and median to describe the center of the data. So I hope you guys are able to understand the measures of central tendency. As the name says, this or all these 3 measures, which are mean, median, mode, they basically describe the center of the data. And if your data does not comes with outlier, and here you have seen that 32 was the outlier, but if your data does not comes with outliers, maybe either on the higher side or on the lower side, we do not have any outlier, then these three measures will fall very close to each other, or approximately they will be equal to each other. So your mean will be equal to mode equal to median. And here you can see I was having average to be 26.46. If I was not having this outlier, which is 32, I would have got this value close to 26 only. Sorry, 26.46 is my average. My median is 26. My mode is 26. In this case, I can say that my data is having a center of 26. Now, if I go to my principal and if I tell to my principal that the average age of my class is 26 with 13 students, then it gives the rough idea to the principal that okay, we have a center point 26 and we have few students above this point, few below this point. If I tell to my principal that the median is 26 with total number of students to be 13, then in that case the principal will be able to do a little bit of math and he will be able to understand that okay, we have 6 students below 26, 6 students above 26. So I hope you guys are clear with measures of central tendency, but there is a problem. The problem is I'm still not clear how the values are varied. So I know that center is 26, but how the variation is there in the data. So am I having the age of the students to be very much varied? When I say varied, that basically means the values are very far away from the center. So let me just give you a very simple example over here. Let's say this is 26, this is 26, and here also we have 26. So in these two number lines, the center is 26 itself. But in this number line that is on my left of the side, left of my screen, the minimum is 15, maximum is 30. Here you can see that the minimum is 20 and maximum is 30. Or let's take it as 29. Now here if you see that the values are very far away from the center, there is a high variation, while here the values are not so far away from the center, the variation is low. So measures of variation tries to quantify this variation. Given a particular data, how much values are scattered around the center. This is what we are going to learn in measures of variation, which is our next topic. So now let's talk about measures of variation. Measures of variation. And I have already given you a very short example, I would say, in my last slide. But now let's try to have a more insightful example which will clarify your doubt regarding what exactly is measures of variation. So let's try to take two examples or two subjects, and I'm just plotting these two subjects to get you a visual picture about what exactly I'm trying to explain. Assume that here the x-axis represent the student ID for both the plots and y-axis represents the marks. These are the marks. So let's say the average marks are represented by this red color line, red color dotted line. These are the average marks, or this is the average marks. For example, you can assume that the average marks is 50 for both the subjects. But for subject A and this is subject B. I'm not just naming any subject, I'm just saying A and B. For subject A, the student marks are scattered like this. So this represents the marks of student number 1. So this is student number 1. Then this marks of student number 2. Then we have student number 3 and so on. So I'll just draw it now because I hope this gives a clear picture about what I'm trying to explain. So this is basically the scatter plot for subject A. For subject B, this point represents the marks of student number 1, this for student number 2, then 3, 4, 5, 6, 7, 8 and 9 and let's say 10. Here also I think we have 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you can see that, and in both A and B we are having 10 students, but for subject A you can see that all the marks or all the students have scored marks which are very close to the average. Most of the people have scored let's say if I just create a band, let's create this band, a dotted band. So most of the students fall in under this band or within this band. While here for subject number B, you can see that there is a lot of scatteredness. You can see that there are data points which are very far away from the average line. There are data points which are also close to the average line. But in subject A, all the data points are very closely scattered around the average line, right? Now, can I say that for subject A, the variation around the mean, so this is my mean, the red color dotted line is my mean or the average line. So M represents the mean or the average line. So for subject A, the variation of the marks around the mean is low. For subject B, the variation of marks around the average line is high. So here, variation around the average line for subject A is low, while for this variation around the average line for subject B is high. Now the measures of variation tries to quantify this. How I can say this is low and how I can say this is high? We need a number, right? We need some quantity. We need a number that can describe this measure or describe this scatterness or describe this variation. So measures of variations are those metric that describes the variation of the data around the center or around the average line. So measures or metric that describes the variation of the data around the center of the data, center or the average. Now what all measures we have? So number one, so I'll write it over here. We exactly have, I think, 4 measures. Let me write it down. So we have range, we have variance, we have standard deviation, and finally we have the coefficient of variation. So let's talk about each of them. Now in order to talk about any of them, we need the data. So let's create some random data. So let's say here we have the data of the marks of a student in one particular subject. And I'm intentionally drawing this table a bit large because we will be calculating a few parameters in order to arrive to the exact quantity that we are looking for. So let me just quickly draw the table. So here we have the student ID, which again runs from 1 to, let's say, 10. 1, 2, 3, 4, 5, 6, 7. Then these are the marks. So I will write XM. XM means marks of students. So let's say the marks are 27, 52, 48, 33, 39, 65 and 82. Now this is my marks of the students. Now if I have to calculate the range is nothing but the maximum minus minimum. It gives you a very raw idea regarding what is the range of my what is the range at which we are trying to work, or if we are talking about the marks, then what is the minimum marks scored, what is the maximum marks scored, and the range is nothing but the difference between max minus min. So my max marks is 82 minus minimum, which is 33, and if you subtract this you will get the range. The second measure is variance, which is a better measure to define the variation in the data. What is the problem with range? Range is again influenced by the outlier. So let's say if there is one student in the class who has scored 100, while most of the student has scored, let's say, close to 33, 35, 39, 40, then in that case also the range would be very high. So it would mislead you. It would give you a misleading idea that students have scored in a high range, but that is wrong. Range gets influenced by the presence of outlier, and that is the reason we don't use range as a measure to make or to understand about how the data is scattered around the center of the data or center line. So let me write it down over here. Range is a metric that gets influenced with the presence of outlier. Now how to arrive to the variance? So we are talking about variance now. In order to calculate variance, we will first of all find out the center, because as I have told you, variance is all about calculating the scatterness or calculating the variation of the data from the center point, which is the mean or the average. So we have to find out the average first of all, the average. And if you guys want, you can pause this video and quickly calculate the average, because we have already learned about it. So just take the sum of all the observation divided by 7, because 7 is the total number of students in the class, and that would give you the average. So the average of this particular marks for the students would came out to be 49.42. Now for simplicity purpose and for making all the calculations very simple, very clean, let's take this number as 49. So assume that the center is 49. Now we have the center. So let me just quickly draw the graph. The same graph that we have seen in the last slide. This is a student ID. These are my marks. And we have the center now at 49. So somewhere in the middle, but 1 point below. So assume this is 49. So this is my 49. Now let's mark all these numbers. So 27 would lie somewhere around here. So this is student number 1. Then we have 52. So this is my student number 2. And then we have 48, which is very close to the average. So this is 48. Then 33, somewhere over here. 33, then 39, maybe over here. Then 65, over and above the average line. And finally 82, which is again over and above the average line over here. So these are my data points. This is my student number 3. This is 4, 5, 6, finally 7. We have 7 data points. Now we will calculate the distance of each of this data point from the center which is average. So when I say distance, I am basically interested in this distance. This is D1, then this is D2. Similarly, this one will be D7. This one will be D6. So distance is nothing, but I'll take the data point. So xm minus xm bar. I hope you guys remember. If I put a bar on a variable, it becomes the average. So this is my average marks, which is 49. Average marks. So 27 minus 49, that will be my D1. 52 minus 49. 48 minus 49. 33 minus 49. 39 minus 49. 65 minus 49, and finally 82 minus 49. Now if I ask you what is the average distance, from the center, basically mean how much on an average a data point is deviated from the center. Now if I have to find out average, I have to take the sum of all these values, right? The problem is that few of the values are above the average, which would result in a positive value. Few of the values are below the average, which would result in a negative value. And if I simply take the sum of all these data points, the positive will cancel out negative. So we would get a very wrong value. And if I know that the center is 0 and we have some positive value, some negative value, then everything will be, you will get a value close to 0, which basically mean there is no variation, which is wrong, right? In order to overcome this problem, I will take distance square. I will convert the positive error or the negative error into the square, so that the positive and negative can be nullified. We can get rid of these positive signs and the negative sign. So let me just quickly write down what we are left with. So this will result in, I'll just quickly write down all the numbers because I have already calculated it. Now here you can see that I'm having minus 16 and plus 16, and if I simply take the sum over all the d, this minus 16 will cancel out plus 16, so I will not get the contribution of these two numbers. Similarly, you can see that I'm having minus 22 plus 33, minus 1 plus 3. So we are having some values which are positive, some values which are negative, and we cannot simply take the sum. So we will take distance square. So 22 to the whole square is, I have already done it, so 484, 9, 1, 256, 100, again 256 and 1089. Now we will take the average of the distance square. So what we have to take? Average of distance square. Now you guys can ask me that, Sumit, why you have taken a square, why you haven't taken the absolute value? So I would have simply taken minus 22 as just 22 and minus 16 as just 16. Now please remember that when we are working with statistics, we are using a lot of calculus also, and as of now I cannot show you where I would be working with calculus, but as we proceed forward, you would see that statistics is heavily dependent on calculus. And when we talk about functions, the function or the derivative of a constant is always 0, and derivative of a square term, which is d square, or maybe a derivative of a function which comes with a polynomial value, can be differentiated. So your calculus does not works with constant, does not works with functions which are constant, and that is the reason we will not be using those, we will not be using the absolute term, and we will be using the square term. So we have to take the average of d square, and you already know the formula, which is summation over d square and divided by n. So if I take the sum of all the observation which are present in the column d square divided by 7, I would get the average distance, or not just the average distance, I would get the average of d square. So this would be 2195 divided by 7, which is 313.57. Now this value is known as variance, which is 313.57. The problem with variance is that you can practically not make sense out of it. I'm not able to understand what this value means. And if you remember, it was d square. D square is equal to 313.57. Variance is also known as sigma square. It is known as sigma square. This is a Greek letter, sigma square. So my sigma will be square root of 313.57, and this would get us 17.65. This is my sigma. Now what is the meaning of this? Now sigma square is my variance, variance is basically my sigma square, while sigma is my standard deviation. Standard deviation is my sigma. So standard deviation talks about the average distance that the data points are deviated from the center. So on an average, the data points are 17.76 marks above or below the mean, and that is what this standard deviation means. How much on an average the data points are deviated from the center, and that is 17.65. Now if this value is very low, which basically means the values are closely concentrated around the center point. For example, if I go back for this subject B, this one, you will get the value of sigma, which is my standard deviation, to be high, while for for A, which is this case, I would get the value of sigma, which is standard deviation, to be low. So if I call this as sigma A and sigma B, then my sigma A would be less than sigma B. The standard deviation in subject A would be less than standard deviation in subject B. When I say the standard deviation is less, that basically means all the observation or most of the observations are scattered very close to the mean. While when I say standard deviation is high, that basically means most of the observations are scattered far away from the mean. Now this gives you a better idea regarding how your data looks like. If you guys want to practice, you can see that we have already calculated the mean, median and mode of the age variable. We were having 13 students and their respective age. We have already calculated mean, median and mode. Now for practice, what you guys can do, you can quickly calculate the standard deviation of this particular data, and then you can try to understand it. So if you have to explain to the principal or to any person about how this class looks like. So we have already seen one segment that this class is having the median to be 26, which basically mean 50% people or 50% students fall below the age 26 and 50% fall above the age 26. Now if you get the standard deviation of, let's say, 5 years, I'm just throwing a value, I have not calculated it, so I'm just giving you this task to calculate this. But let's say if the standard deviation of this data is 5 years, then that basically means on an average the students are having 5 years above the central point, which is 26. So let me just quickly draw it. So let's say this is my student ID, this is my age, this is my center, which is 26, and if I'm having a standard deviation of 5 years, that basically means I'm having few students who are above the age, above the middle age by 5 years. So 26 plus 5 will give you 31, right? And 26 minus 5 will give you 21. So you can see that you can say that most of the students in your data are between 21 to 31, right? So using the measures of measures of central tendency, we get the central point. Using the measures of variation, we get how the data is scattered around the central point. But there is a problem. The problem is, let's say if I'm having two subjects, let's say I'm having a subject maths having a standard deviation of, let's say, 15 marks. And then I'm having age, having a standard deviation of, or maybe let's say I'm having another subject science, having a standard deviation of, let's say, 20. Now, can I compare these two standard deviation? Can I say this is high and this is low? Well, we cannot do that. Using standard deviation, we cannot compare the variations among the series. Now, please remember, this is a very important note, that standard deviation talks about the variation in the individual series. And we cannot use it to compare the variation among the series. So how we can compare the variation among the series? For this, we have the next measure, which is coefficient of variation. So now let's try to understand coefficient of variation. Coefficient of variation. As I've told you, standard deviation is limited to describe the variation within that series. So if I'm saying that the standard deviation of the maths marks is 15 and the standard deviation of science marks is 20, I cannot use these two individual standard deviations to compare the variation among the series. For that, we have a different metric known as coefficient of variation. Let's take one example. Let's take two series. Series X, which is having 1, 2 and 3 data points. Series Y, which is having again 3 data points, 101, 102, 103. Now if I take the average of X, which it will came out to be 2, average of Y will came out to be 102. Similarly, standard deviation of X will be 0.81, standard deviation of Y will be 0.81. Now, both X and Y are having the same standard deviation. Can I say that they have the same standard deviation, or can I say that they are having the same variation? If you closely observe, you will find out that this is not true. While in the series X, you can see that the third element, which is 3, is 3 times of the first. While in series Y, I cannot say the third element is 3 times of the first. Right? So they both are not having same variation. X and Y are not having same variation. How we can compare the variation? How I can say that X is having more variation, Y is having less variation? Because standard deviation is getting us the same value, 0.81, 0.81. How we can get, or how we can compare? For this, we have coefficient of variation, which is nothing but the ratio between the standard deviation to the mean of the data. The standard deviation to the mean X bar. For coefficient of variation for series X would be 0.81 divided by 2. For Y, it would be 0.81 divided by 102. So this would be 0.405 and this would be 0.007. Now if we closely look into these two values, which is 405, so 0.405 and 0.007, this particular series, which is series X, is having the coefficient of variation of 0.405, while series Y is having the coefficient of variation of 0.007. And I have already told you that the series X is having more variation than series Y, because in this series the third element is 3 times the first, while I cannot say the same thing for series Y, right? So when we have to compare two series, or we have to compare the variation among two or more series, we look at the coefficient of variation. A higher value represents higher variation. So this series is having higher variation when compared with series Y. So using coefficient of variation, we can simply compare the variation among the series, and we should not be using standard deviation. I hope this makes sense. Now here you can see I have taken one simple example, and here we'll be using all the measures, which is measures of central tendency and measures of variation, to understand how these three products are performing in terms of sale. And please remember, this is the number of units. So for product number 1, in month 1, 929 units were sold. Similarly, for product 2, in month 1, 1240 units were sold, and so on. So we can quickly find out the average, median, and mode for each of them. So is equal to average of this particular column, and I can simply extend this formula to all other cells. Similarly, median will be is equal to median. I want median of all these cells, and I can simply extend this to all other cells. And then we have mode, so is equal to mode. Now here if you carefully observe, I do not have any mode, so my mode is not available, and I have told you previously. So if I do not have any observation which is duplicate, or which is repeated for more than one time, which is having the highest frequency in our data, we will not be having a mode. So we only have average and median. So I'll simply delete this because we don't have a mode. So let me delete this. Now if you compare the average and the median, you can see that for the sales of product number 2, the average and the median is quite close to each other, while the same thing can be viewed for product number 3. But there is a difference. There is a vast difference. I would not say vast, but there is quite a good difference in the average and the median for product number 1. Let's try to look at the measures of variation also. So we will calculate the standard deviation. So is equal to STDEV, and we will use this STDEV, this one, a standard deviation. And I can just simply extend this. And now we will calculate the coefficient of variation, COV. So this is given as the standard deviation divided by its average. Now these are the numbers which we have to carefully read and make sense out of them. What we can conclude about these three products? let's try to understand them. Now if you carefully observe, and I would start with product number 2 first. In product number 2, you can see that the standard deviation is very small, while the coefficient of variation is also very small. Here also you can see that coefficient of variation is 0.23, here it is 0.22, but here it is 0.04, which basically mean among all these three series, the lowest variation is with the sales of product number 2. Also, if you look carefully, the median and the average is very close to each other. Also, the average is highest among all the three products. So what I can conclude about product number 2? Number 1, the product number 2 is very stable in the market because it is not having variations. In month number 1, same sale; in month number 2, approximately same sale; month 3, same sales, and so on. Also, it is always consistently high, and that is the reason the average is the highest at 1262.5 units. For product number 3, a similar behavior can be seen, but on the lower side. The average is 556, which basically means when compared with product number 1, product number 2, and product number 3, when compared with product number 1 and 2, the sales of product number 3 is on the lower side or the lowest side. While the coefficient of variation for this, which is product 3 and product 1, is approximately the same, which basically means they both are varying at the same rate. The variation is approximately the same. So you can assume that one, which is product number 3, is on the lower side and it is varying around that. Product number 1 is on maybe second lowest and varying around that, and product number 2 is on the highest. So if I just color code them, I would say product number 3 would be coded as red. Product 1 I can put it as yellow, and 2 I can put it as green. And the reason I'm putting it as green because it is the most stable product in the market, while sales of product number 3 is on the lower side. That's the reason we have assigned a red color, and product number 1 is having the sales between the highest and the lowest sale, which is product 2 and product 3, so we have assigned a yellow color. Now you can see that using these measures, we can better make conclusions about the data. We can better explain the data, and that is the power of descriptive statistics. So you have seen that in this particular descriptive statistics segment, we have talked about how we can explain the data. We have talked about the various types of variables. We have talked about qualitative, quantitative, right? Then we started our discussion around what are the various measures of central tendency. We talked about mean, median, mode. Then we compared all of them. Then we talked about measures of variation, where we looked into range, variance, standard deviation, coefficient of variation. And finally, we have concluded all our learning into this table, where we have compared the sales of these three products to conclude about which product is better and which product is not good. Now, this is what the application of descriptive statistics is. There is one small topic which is very related to outliers. I'll just quickly explain you that. Though that is not so much common in the descriptive word, but quite important to understand. I have told you about outliers, right? Over here. So I have told you that in this particular series, where we have the age, 32 is considered as outlier. And what is outlier? Outlier is that observation which is very different from majority of the data. Now there is one particular topic which is known as the leveraging point or leveraging data point. What is that? Let's take one very small example. So let's say I have this data, and this is the stock price. So here we have the day of the month, and here we have the stock price of a particular stock. Let's say on day 1 the stock price was somewhere around here, then over here, then over here, then here, then here, and one day it jumped over here, then came back to its normal position like this. Now at the very first, like if I provide you with this data, all of you will say that this is outlier. This is particularly the outlier data point, which is true, this is outlier. But as soon as I provide you one additional information, your answer will change. Now if I tell you that on this particular day, let's say this is day number 15th, or maybe let's say day number 25. So in the 25th day of month, let's say March 2023, let's say the stock market or the stock exchange, or let's not talk about stock exchange, let's say this company, let's say this is the stock price of the company Reliance. So on 25th day of March 2023, Reliance announced a major product, or they made they basically conducted a conference. They conducted a meetup in which they announced a major change in their policy or major change in their product, due to which the stock price suddenly raised to this particular point. Now this is not an outlier, this is the leverage data point, because it has been leveraged due to this event. So I cannot say this is an outlier, this is a leverage data point. So there is a difference between outlier and leverage data point. If I go to this particular example of age, I cannot say this is leverage data point, because this person has not, or the age of this person has not been impacted by any external factor. So I cannot say this is an leverage data point, this is just an outlier. But in this case, where we are considering the sales of a particular stock price of a particular stock, let's say Reliance, this data point is the leverage data point, because it has been influenced. The jump is because of a particular external factor, which is nothing but the announcement, right? So I hope you guys are clear till this point. Now we will move forward to the next particular discussion, which is probability. I hope this module was informative and really useful for all of you. If you like this video, share it with your friends, give this video a big thumbs up, and don't forget to subscribe to our Scalers YouTube channel.